Hey guys, NJ here. So today we're doing a build video on this brand new product by Eachine. This is the Tyro99. Now this caught my eye because at $99, and that's what the 99 in the Tyro99 stands for, and I think it's actually less than that already. This is a seriously comprehensive beginner's kit to get into the hobby, and it's very easy for, I guess, the more advanced pilots, people who've been in this for a while, some reviewers, just to turn around and slate this thing and say, well, you know, this part isn't that good and this part isn't that good. When you're talking about people who've been in the hobby for a while, you know, and this includes me, I could spend $100 just on a set of motors or just on a flight stack. I mean, it's crazy how much money you could plow into something. So you can't look at this with the same eyes. If, however, you're just getting into this and you want something where you know all the parts are there that you can put together, with the exception of a receiver, that's the only thing that doesn't come with it, but it comes with everything else. You know all the bits are going to go together and work. It's not too complicated. There's not too much soldering here. It's kind of 50-50, so it's not throwing you in the deep end, but it's helping you develop some skills that you will be needing later on. This is a really compelling package. There are lots of other reasons for why I think that's a good idea, but it's very much in the ethos of being a model hobbyist. Building this stuff yourself, you get to learn how things work, as opposed to just buying a bind and fly, plugging it in, and I mean, that could be dangerous as well. You're learning how this whole thing ticks. You'll have a greater appreciation for it, and you'll be going into this more informed. So if you're more of a veteran pilot and you're looking to recommend something, I think this is a really great kit for the price. Now, that said, I will say there are a few components that aren't that great on here. One of which I say is the deal breaker that needs to change, and you may have spotted it if you've seen this in the wild anywhere else, and that is the camera. The camera that comes with it, what I think that is personally, here it is, I think this is old stock, that they've just got a load of these and they're like, yeah, just chuck this in the kit, because there's a lot of bits on here that are really kind of tech from 2, even 3 years ago. For a start, it comes with a 2.8mm lens, which is a very, very narrow field of view. You feel very boxed in. Really, 2.5 is an absolute minimum. 2.3, 2.1 I personally like to see on my cameras, so 2.3 to 2.1 would have been ideal, and it's kind of the standard on most cameras. Didn't come with this. There's no OSD plug on the back of this either, so you can't adjust any of the settings, and the picture and the light handling, unfortunately, is awful. So that did not make it into my build for more than 2 minutes, and that is where I would consider applying your first upgrade. Get a good camera, it will transform your experience with this quadcopter. Now, the other thing that's worth a mention is the KV and the fact it's on bi-blades. Now, personally, I don't think this is an accident, and again, I think this is brilliant for beginners. Now, the KV is 2150, and again, the seasoned pilots will probably turn around and say, oh, on 4S, that's way too low, etc., etc. Now, what that's doing, and especially on bi-blades, is first and foremost, it's limiting the power of this quadcopter. That's a great thing when you're learning. You don't want a super twitchy, overpowerful quadcopter. You want it to be the other way. You want it to feel a bit more gentle and something you can learn easily with. So this puts a nice limiter on the power, and it will still be acrobatic, still fly great, but it just brings it into a manageable state when you're learning to fly. The other thing is, at this low KV and with bi-blades, you get a very efficient setup. So you're spending way more time in the air. You're not burning through this in 3 minutes. It'll be more like 4 to 5 minutes of flight. Staying in the air, again, very good for beginners. Now, this is up to 5S compatible. So if you wanted to take the voltage up, and I think this would transform into being quite a little beast, or you could stick with 4S and just change these props out to something like a tri-blade with a heavier pitch, and you'll be absolutely fine. So these are all things that say this quad can grow with you. Yes, I do think the camera needs replacing right from the off, but even if this whole kit for under 99, which I think is at like $93 or $92 at the minute, came without the camera, it's still an amazing deal. And the other components on there are fine. There are some little things in there that I will go over in the build video, but that's my first impression overview and a little bit of a talk about the quadcopter itself. So with that in mind, this build video is for beginners. It's very comprehensive. It took me ages, and I'm going to hold your hand from start to finish putting this thing together. I'm not skipping through anything. We will do this, and that's why it's long. I'm not dividing it up either, so you don't have to hunt for part twos. It's all there. Once you've got to the end of this and you've got this thing built and you've followed along with me all the way, and I'll put in some tips as we do that, like my tips on soldering, etc. Once we've done that, we'll then come back and I shall do some more testing. I will show you some flight footage, show you what I'm going to put this thing through its paces. And then we will also maybe do a 5S test and some of the more exciting stuff. But on the whole, my regular subbies, if you are looking to recommend something to get people into the hobby, I really do give this a thumbs up. And if you're a beginner and you've just got one of these, let's get down to the bench and let's get started. In terms of what's in the box, you get stickers with their logo, if that's your sort of thing. What else we got? In the corner, we have the flight control stack. Now, this is an F405 processor, which is great that they're putting in an F4, and I believe the target is the Maytech F405, so great, that gets approval from me. Lots of plug and play parts on here, so they've minimised the amount of soldering needed, which is a good thing. You will have to solder your motor wires and also the XT60 on there, so there is a bit of soldering for you to do if you're learning, but you need to learn solder, so that's no bad thing. Nice kind of 50-50 on that front. They've put a capacitor down here, low ESR capacitor, which looks decent, 105 degrees C, which is good, high temp. It is only 25 volts, unfortunately, which kind of makes it 3S functional. I think if you want to run 4S, which you can, or even higher than that, you need to be on 35 volts at a minimum. But this is fine, it'll do something, and it's good to see manufacturers sticking these in as a standard, because we all know they do a good job in helping protect your electronics. So yeah, that's good. D-Shot 600 4-in-1. Yeah, not much more to say about that other than that is a good choice. We have here the VTX, again plug and play with the JST connector into the flight control stack. Keeps things nice and easy, so not much, well, no soldering to do there. You've got a display on the top. It's been a while since I've seen this kind of form factor, actually. This is quite old school. Great to see an MMCX connector, nice and robust. We want robust connectors for beginners because the connections tend to be where things get ripped off and beaten up, so that's a good thing. No smart audio, sadly, but it's 25, 200 and 600 milliwatts, and you will have to switch that via a button, so wherever this gets built it will need to have that button accessible. Now here, I will give you a heads up now. I've had a quick look at this camera's picture. It is a narrow field of view. I'm not sure what the FOV is, but it's definitely not a 2.1, which is what I really think most cameras should come with these days. I'm not even sure if it's a 2.5. It might be the dreaded 2.8. But the FOV is not great, the lens isn't great, it's not a very nice picture, and there is no OSD plug in here, no pin for the OSD, so we can't change any settings in this camera. So this is probably going to be my first chuck away item. You can use it if you just want to get this thing in the air, but I would recommend that you spend a few bucks on a on a Swift or a Foxeer Arrow or something similar of this size. I think a lot of the micro cameras come with brackets now that will make them for a full size mount anyway. Check that before you buy a camera, but there's no reason not to have a good picture, and it's a big part of the experience. So really, I would suggest kind of not bothering with this. You can use it if you want, but I'm gonna say no on this item for now. The motors and the props. Let's talk about these two things together. You'll notice we've got some. They look like clones of racecraft props, but they are bi-blades. 38 pitch, 5-inch in size. Now we've got plenty of those in there of both directions. Looks like I've got them in clear. It looks like the insulation is plastic, so obviously they're kind of not very nice to work with, not easy to solder with because they're become very springy. It's not a problem with the wire, it's the insulation. So they're plastic insulated. Really would have been nice if they were silicon insulated, like most of the wires that we work in terms of components. But the build seems fine of the motors. They feel nice and smooth. The gap between the stator and the magnet seem decent. Good size arc magnets. Build quality seems nice. So yeah, I'm sure these will be absolutely fine. We'll see when we get on to test flying them. In here we've also got, well, we've got a couple of pieces of foam, I think for battery mounting. We've got a large sticky pad, maybe that's for the battery. We've got a battery protector plate. Great idea. Again, if you're a beginner, this will stop you puncturing your lipos when you make horrific crashes rather. So that's a good idea. Well done. There are the side frame and what looks like an SMA mounting point for your antenna. Look to be aluminium, nicely anodized. That looks good. Hopefully this will be a nice strong build. We've got a bunch of heat shrink by the looks of things, so yeah, we'll see what that's for when we get onto the build. These look like 3 side screws for the camera, I would say. Nice they've given you one extra, because there's always that time where one vibrates out because you forgot to do it up or add some Loctite. We've got some Eachine, 2 Eachine battery straps, very generic. We have a couple of these carbon print tools for tightening the prop nuts and the SMA. I actually think these are really good. They fit in your bag and they work fine. No problem with those. Good idea. We have a carbon AK-47. Weird. We have the XT60 with some, that actually looks like quite thin gauge. That is, what is that? 16 AWG. So yeah, I'd probably say at a minimum I'd want 14 AWG, but it really won't matter. At this length, we're not going to be reaching any limitations of amp draw with that, so it's not a problem at all to go with that. You can always upgrade that later if you want to run start getting more ridiculous power out of the thing, but that'll be fine to start with. We can see our camera plugs, bits and pieces to keep parts of this quad all nice and plug and play, so that's great, all nice and organised. We have the MMCX to SMA, quite short, so I'm guessing that's going to be located quite close to wherever the VTX is designed to be put. We have some zip ties, we have a generic Eachine Pagoda antenna. Pagoda's good antenna, no problem with that. We have a big bag of hardware, standoffs, all the bits and bolts that we're going to need. We have finally the carbon, and it looks like 5mm arms, so nice tough arms there, and they're quite a skinny profile as well, so that's good. That will make for a nice, again, help with the efficiency, keep it a bit more low drag, and yeah, I think this is hopefully going to be a decent lightweight build but strong. Looks like the bottom plate has some captive nuts on it. That's quite a nice idea, keeps things easy to mount. Yeah, no real complaints about everything I've seen there except for the camera. I'm not going to go with that, but you can if you want, but I suggest you change it. So we can get to the build. So what we have here is the bag with all of the carbon parts in. We have the aluminium side plates and the SMA holder, and then we've got the hardware bag opened up. Now don't worry too much if there's odd numbers here. What they've actually done is they've given you a fair few spares of everything, so you don't have to worry that you might have a screw missing. It's actually the reverse. You've got extra of everything. Now there's quite a difference in sizes. Normally with quad builds you tend to have maybe 1 or 2 at most 3 different lengths of M3 bolts, but here we've actually got quite a lot of different sizes, so the best thing I suggest you do is just to organise them separately like this. If you haven't got a mat like I have here where you can actually look at the measurements of each to get a note of the length of each one, then I suggest you grab one. There's a link in the description to this mat. You can also get cutting mats which have the rule 1 cm squares on. That's useful, but get an idea of what the lengths of each of these are. There's a manual which is linked in the description for this. It's pretty straightforward. It's more of an exploded diagram, which I like. It's like building old Lego models, same kind of thing. That exploded diagram will give you an idea of, it will actually show you, if I put a picture down there you can see, they actually colour code each of the different sizes of M3 and how many of them there are. So for instance you can see there are 7 of the M3 by 4mm, and the 4mm refers to the length of the screw. Okay, so as with most mini quads, we're going to start from the base and work our way up, and that is going to be with this little X brace that will go underneath the arms where they all meet in the middle. Now this part appears to be symmetrical, so that's all good. If you imagine that this is the front of the quad, the way you want these arms orientated is so that you have them this way round, so the curved section goes towards the inside. There's no real reason why you couldn't have it the other way if you wanted, but we will stick to the design as the plan suggests. And it does say to start with we need the M3x16, which will be the longest ones, which are here. So we're going to go in through the underside of that guy, through the arm like so, and then what will happen is, if that's going to be our front, again this part is also symmetrical. We're going to have this with the captive lugs on top. This guy will go through like so, and then on top of that will go one of these bolts here, so that will go down. And remember, this is the top side, that is the underside, so we're going to do that, and then I'm going to repeat that with the other 4 arms. One thing to note is that when you tighten this bolt up, don't tighten it fully, just snug it, but make sure that you can still move this around. We want to make sure all the bolts are in before we actually start tightening anything down, so that everything can seat up properly and be nice and true. If you absolutely jam this down super tight, you might find you have a real problem getting the other parts in and lined up. So we'll get everything in snug but not too tight. Once it's all together, then we start tightening up screws. Okay, so there we go, we have that put together now. So we've got the top plate here, we have the arms orientated so the curved part is on the inside on both, and then if we flip, this is the underside of the plate. You can see we've got the X brace, we have the 4 M3x16 bolts that have gone through there, and the nuts on top, the thread lock nuts. So that is the first part done. Now we're not going to put the screws through here just yet. The next screws along on the arm, because those are to hold the flight controller. We don't need to do that yet. We're going to do the screws that screw into these captive nuts here, and those are the M3x12mm. So locate those out of your pack. We're going to go in through from the bottom on those middle 4 holes, and they will go straight into those captive nuts there. And with those 4 in, you can see when they're snug that they are flush with the top of the captive nuts. Okay, we're going to put the base aside for 1 second, and we're going to assemble what we call the top pod. Now that will be these 2 aluminium side pieces here, and they need to be a mirror of each other, so let's do exactly that. And these are also symmetrical, so it doesn't really matter which way around you put those, but make sure they match up. Now these screw holes here will mount vertically onto the top of this plate. So this is the top and this is the bottom. So we're going to line both of those up and make sure they're mirrored, so we have one for each side like so. And then the holes that we're going to screw these side plates to the aluminium parts, we're going to be doing the top out to here. So we're going to do this one, we're going to do this one, and then we're going to do this lower one on the back here, and those are going to be secured with the M3x6mm. So we'll do 3 for this side, 3 for that side. Okay, so the next thing we're going to do is we're going to take one of our side plates and we're going to mount the camera to the inside. So that's going to go in here like so, and the reason we're doing that now is because it's going to be a much more tricky time to get the camera inside of that once we put the side bracing across. So we're going to do that now. A couple of things to note, as I have mentioned already, this is the lower side that mounts onto the base plate of the quad, and this is the top. Now that's important because when you mount the camera, it has to go so that the white connector is at the top. If you mount it in this way, so that the white connector is at the bottom, then your picture will be upside down when you go for your first flight, and that will be very frustrating. So this is going to go inside. Okay, so the carbon plate's towards the outside, we're mounting on the inside through that middle hole there, and that is going to go through the whole of the camera. Now I'm not going to use this camera. You can if you want, but I genuinely think this is a poor choice of camera, and you're only going to want to change it almost immediately. So what I'm going to do is go with a I've got a spare micro swift here. Now the only problem with the micro swift is you'll see they're actually different widths. So what you need to do is get, if you want to run with a micro cam, is get an adapter plate. This is one from a run cam kit, and what that will do is when I put the mount this into that frame, that will turn this into a full size, full width camera. There's another advantage as well. One thing I also don't like about this camera is when it's lined up with the mounting hole, you can see the lens pokes ahead of the front protection from this metal. Really, you want the lens kind of level with it or just behind it where it will be protected from a front crash. So yes, that's another reason why I don't really want to run with this. However, the shorter, stubbier focal length of this lens on the Micro Swift here means that when this goes, I'll just put it on the other side of the plate so you can see it, when this is lined up with the hole which is about there, you can see this is now just behind the aluminium plates. So when that goes inside, like so, the right way up of course, as I just mentioned, the lens is level, so the frames won't come into view, but it will help protect the lens in a frontal impact. So that's why I'm going with this camera. I'll put links to this in the description as well if you want to do the same. With that mounted in, you can see, as I mentioned, the white plug of the camera towards the top, and you can see how this will be adjustable in terms of the up tilt of the camera. So with that done, what we're now going to do is add a couple of the other parts here just to that side before putting the other side on. So this here is where the VTX is going to be mounted. So we're going to put that guy on the top, doesn't matter which way round it goes. And those bolts are going to be the M3x4. So we're going to need 2 on there, and then there'll be 2 on there when we join it to the other side. One thing just quickly to note, the materials of these screws, they're okay. They're a little on the soft side for my liking, but they'll do the job just fine. And when you're screwing metal screws into, especially into aluminium, there's a very real danger that you might end up cross-threading and then ruining it, and then they'll get jammed in there, and then you're really in trouble. So one little tip that I like to suggest is when you put the screw head in, before just turning it clockwise and screwing it in, back it out until you hear that the threads are seating. So if I go back the wrong way but apply downward pressure, you'll hear that noise. And when you hear that click, those are the threads meeting and aligning. Then when you go forward, you're perfectly aligned and you'll have a good time without any cross threading. So if it does feel at all like it's jamming a bit, back the screw out, make sure you're aligned before you confidently screw down. Next we do this little guy, and this is going to go into this little recess here, and it uses exactly the same size of bolt, which is the M3x4mm. And then lastly, we're going to add the SMA antenna holder here at the back, and that will be using these longer M3x12mm bolts. So this will go on this hole here and mount to the back. Again, don't snug this down too tight, there'll be some adjusting. We also have to mount the antenna to this, so just mount it loosely for now. So you should end up with something that looks a little bit like this. Now all we have to do is to get the other half, and we're going to put this on to the other side and repeat with the screws that we used for this side. There we go, so that top pod is now all assembled and looking good. As you can see, this is the lower, here is the top, and you'll notice that connector that I just mentioned is towards the top of the pod. Now once we build the lower deck, so we've got to put the ESC, the flight controller, and the motors and wire and solder those up. We will then be able to run the various connectors to this, add the VTX, add the SMA for the antenna, and then this will go down on top of that like so, and we'll have something that's starting to resemble a mini quad. The next thing we're going to do before we finish with the top pod for now is just to put this little MMCX to SMA connector here. So this is going to take the video signal from your VTX, which we will be affixing here so that we can see the display for the channel and band, and also get to the button to change it. That's going to connect in there to the MMCX connection, and then it's going to go through here, and your pagoda antenna is going to connect to the top. Let's get on to sorting out this deck. Now we're going to need to put the flight controller on very shortly, but before that we are going to get the motors, and we are going to feed the motor wires inside of this heat shrink. Now when you look in the kit, 2 of the motors you'll notice will have silver nuts on them, and 2 of them will have black nuts on them. Now this is not actually a colour mismatch accident. This is something that some manufacturers decide to do by way of making sure the prop doesn't slip when these things are rotating at very high RPM, or under instances where there's a lot of torque applied to the propeller. In short, there's a more in-depth discussion on this, and we'll talk more about this when we get up to the point of actually flying and putting the props on, etc. But the short version for now, and for the purpose of our build, is that you have in opposite corners, you have the two motors' rotation direction being the same. So in these corners, for instance, these motors are going to be moving in this direction. So in other words, they're going to be spinning counterclockwise, and they're going to be spinning clockwise in these corners. So clockwise rotation, counterclockwise rotation. Why is that important? Well, for these motors, what they do is they put, the black nut is actually a reverse thread. So whereas the silver nut you would normally do, in the old engineering term, lefty loosey, righty tighty, the silver nut follows that standard thread rotation, but the black nut is reverse rotation. So actually clockwise loosens the nut and counterclockwise tightens the nut. Now the reason for this is so that if I was to take this one, for instance, I can tell you now that the rotation, imagine this is the back of the quad, that's the front of the quad, that this motor will need to move in this direction with the prop spinning out and in towards the middle. Now, while this is spinning this way, with the prop in here, applying a large load of torque, if I was to hold that nut still and we apply the direction of rotation of the motor, what's actually happening there is it's spinning off the prop nut, which is obviously a bad idea. However, if we use this one, which has the counter thread, if I loosen that a bit, and now we have the direction of rotation this way, what this is actually doing is serving, there you go, it's completely tightened up that nut. So the harder this motor accelerates and the more torque that's applied to it, the more it will serve to keep this nut tight. So all we need to know for now is if this is the back of the quad and that's the front, and it's symmetrical at this point, so it doesn't matter which way around this quad is. We just have to remember the big dips is on the sides. What we have to do is make sure that the back right is going to be with the black nut and the back left is going to be with the silver nut. And then when we do the front two, you're going to have a silver nut on this opposite corner and a black nut on this corner. So what we're going to do here, because this plastic insulation is not the greatest, what we're going to try and do is just to make sure these wires are nice and straight, just pull and apply a bit of tension and just make sure that they end up being nice and straight and even like this. And then what we're going to do is hold those together because we want them to stay nice and flat like this, and we're going to feed these through this heat shrink. And what we're going to do is we want these three wires on the top side, so I'm just going to feed these through until we get them poke out the other side, which we'll see there. And at this point, a handy tool to have will be a set of these. So any kind of you could always go and borrow the eyebrow tweezers from the missus if she's not looking, but you just want to pull these motor wires through like so, so that they might grip a little bit, but because this plastic does seem to want to grip the heat shrink, but pull these through like so, just get them all nice and even so that the motor is more or less over those holes. And then what we want to do is just try and get these wires as centre as possible and nice and flat like so. Before we apply heat to this, we need to make sure that we screw these down. So you'll notice here, if we pull these across, it's a bit hard for me to do this on the camera, you'll see there's a point at which this will line up like that, both with that hole and with three of those screws. And the screws that we need to put in, you'll have a big collection of one size here, and these look to be about 7mm, I would say. These are the ones that will go through. The way you can tell is if you push them through, you can see you end up with about 2mm of extra there, which will go into the base of the motor legs there. Okay, so just like when you're torquing down a car wheel, you just want to do them in opposite, so I'd start with these two, then the third one, and then just go around them evenly and tension down at that motor. Hopefully you can see now that the motor shaft is dead center of that hole, and if I spin the bell housing, there's no fouling of the inside of that shaft on any of the surrounding carbon, so it's nice and dead central, everything feels good. And then if we spin that over, I've got these wires channeled just poking out the top here, and now I'm just going to put the heat shrink. I'm going to do this very carefully, just try and get this shrunk down, and then we will move on and repeat this for the other arms. That's all done, all the motors are on. We have shrunk the heat shrink with the wires on top of the arms. Everything is spinning, nothing is binding, so we know all the motors are mounted nicely, and we've got these looms sticking out the top in bundles of 3, and those will be wired to our 4-in-1 ESC via these little solder tabs on each side. Now the next thing to do, there was, if I just point to them, there was the middle holes on each arm. We did the outer nut, we did the captive inside nut, and then there's these ones here, there's 4 of them, one there, there, and here. And we need to put the 13mm in length screws, which are these ones, those need to go through, and you can see I've popped one in the middle here. You're going to put all 4 of those through, and then those are going to mate to the nylon standoffs on the underside of our 4-in-1 flight stack, 4-in-1 ESC should I say. So there is a direction that this has to go round, you can't just put it any way round you want. We're going to put it so that the arrow, you can see there's an arrow there, the arrow is pointing towards the front of the quad, okay? And as long as we know, because at this point this frame is symmetrical as I've mentioned, but these parts have to be on the sides, okay? So that is the front. I'm going to say that's the front, that's the back, but you know, it doesn't matter. We can say that's the front, that's the back. The point is that these are on the sides. So we're going to use those screws, and we're going to mount and screw down this flight stack. So the capacitor's coming out the back, the arrow is pointing forward. One quick note, when you are screwing these in, these are going into nylon. They're not going into metal like the outside ones here that are going into these actual, are threaded on the other side by a metal nut. You are screwing into nylon. Do not over tighten these, or you will just strip these standoffs and then you'll have to replace them. There are plenty of standoffs in the kit, which is fine, but you just want this a little, you want to snug it up and then just give it maybe a quarter of a turn just so it feels good and everything feels solid. Don't go crazy on that. Okay, so it's now time to take these little bundles of 3 motor wires and wire them to our ESC board. To make things easier, what we're going to do, I want you to take off these 4 nuts here, the plastic nuts that are holding the flight controller on top of the stack there. I want you to take those off, and then we're going to pull this guy, take that off, and then we're left with these 4 rubberized standoffs. You'll see these are the ones that move around. Now, what I want you to do is whatever ESC side we are working on, so I'm going to start here on this side, it doesn't matter which one you start with, take off just that one standoff. The reason we're doing this is it's very easy, especially if you're not very good at soldering or you're still practicing, to end up burning this stuff, and you'll get very used to the smell of burnt nylon and rubber and God knows what where you slip the soldering iron. So just take off the one, leave the others down that are helping keep the board in place. Just take that one off, and we've got lots of room and lots of light to work on this. Now you'll see we've got 3 on the corresponding side that are going to be for these 3 motor wires. It does not matter which go to which, so we're just going to go for the neatest option possible. We can change the settings of the motor directions in software, so each one of these wires can go to each one of these 3 in the corner, these back 3 for these 3 for these 3, these 3 for these 3. Very, very simple. That's all we need to do. So let's talk about the soldering and how we're going to get this prepared. Now, I don't like to have loads of extra wire flapping around. And the other thing to know here is that the battery strap to hold the main flight pack under here is going to pass through this gap in here. So the last thing we want to do is have loads of motor wires connected up round here or under there where it's going to get in the way. So we want to try and wire this as neatly as possible. Now the temptation, if you've never done this before, is to leave these at their standard lengths and just stick them into the holes there and add a bunch of solder. And while you could do that, you can see the kind of mess you're left with, and this stuff can get snagged on branches, and you know, these mini quads are going to end up in all kinds of foliage and God knows what else. So what I always suggest you do, and this is a good practice moving forward for when you get onto your other quad builds, is to cut these to length. It's not difficult, but we're going to make it as nice and bespoke as possible in the build so that this is very tidy and neat. Do things properly, you will only do them once, as opposed to doing a shoddy job first time, something breaks, something gets snagged, something gets ripped off, and you've got to do it again. Do it properly, you'll do it once. Hopefully this will give you a nice close-up view with this magnifying glass of what I'm doing here. But first things first, make sure your soldering tip is nice and shiny. Clean it, use a water and sponge. That works. Personally, I like using wire wool. Just make sure that your tip is nice and shiny and clean. You don't want to be working with a gunky tip because nothing will stick to it. So I'm just going to put a little bit of solder on the back of this tip here, and it's all about surface contact, so to get the heat to transfer and for the pad to heat up quickly. Nice hot soldering iron, and then I'm going to introduce the solder directly onto the pad as I make contact with the pad itself and the soldering iron. So I'm going to press this down, I'm going to introduce a bit, I'm just going to bit more, there we go, and I've got a nice amount of solder on that pad. So I'm not going to be doing the poke it in the hole method. This method is going to work far better, and it's okay to be a little bit liberal, get a decent amount of solder on there in preparation. So I'm going to do these three. Straight after doing that, just give it a little bit of a clean again. No bad thing, just to keep the tip of your soldering iron in good condition. So you should be able to see now, see those shiny solder there just waiting and prepped, ready to have the wire come and meet it. You've actually got the ability to solder on both sides of these pads. So I think what we'll do is we'll use the furthest wire away, which is this back one here. Like I said, the order doesn't matter, and I'm going to cut that to length, and I'm going to leave a little bit of slack because I need to be able to get to that bolt maybe if I need to replace an arm, but just enough slack. I don't want loads of wire hanging around, and especially not this much length. So I'm going to add a little bit of slack, and then I'm going to move it to the position where I know that is going to mate perfectly. So I would say about there. I've got a little bit of slack on the top, and I want this just to meet this back pad here, this one that I'm pointing to. So I'm going to find that point. I'm going to just pinch it with my tweezers here like this, and then I know that that little part in there just on the inside is where I'm going to snip the wire. I'm now going to go in with the tweezers and just snip that part off. There we go. So now all I need to do is just remove enough insulation, and really don't take loads off. You just want enough insulation off there to make contact with that solder pad. So you want the solder to go into the joint, and then after that you want insulation. You don't want to strip back loads and have loads of exposed wire. That's just asking for problems and for shorts, which obviously we don't want. So what I tend to do, there's a few ways to do this. You can use a wire stripper if you've got one. If you're like me and you're quite happy to do this and you're good with a craft knife, you can literally just make a few very slight incisions into the plastic insulation. As I said, this is so much easier if they'd just used silicone wire. I think they've made your life more difficult by doing this, but I do that, and then I literally just pull it off, pull the end off, and then I'm left with a little bit of exposed wire at the end, which you can see there. Where we tin the pad, we're now going to tin the wire. So this time I'm going to put a little bit of solder on the top, like so, and then I'm going to touch it to the wire, and I'm going to introduce a little bit of solder as we go until the flux. There we go, so the flux carried that solder into the wire, and we don't need to put lots in, we just put enough in to tin it. So we've now got two surfaces that are prepared, the wire tip and the solder pad. The next thing to do, use a little set of these, because you're going to burn your fingers otherwise and just end up swearing at your quad. We're going to get that wire, and then what you do is place it down so you can practice how you're going to introduce that to the pad. And that's exactly what we're going to do here. So I'm going to heat up the pad, not the wire, okay? I'm going to heat up the pad until I can see that solder flowing and melting. I'm going to introduce the wire. I'm going to make sure that it's all flowing nicely. I'm going to pull away the soldering iron and just keep very still until I see that set. So, heating up the pad, introducing the wire, moving the soldering iron away, and there we go. We are done. You should be able to see where that's mounted. Let me try and get the angle right. You can see we're not going to get in the way of the battery strap, more importantly. Okay, so that is the first one done. Now the second one, rather than get the next wire along, and we could just mount that also to the top, but unless you're very, very good and accurate, you can do that and just cut to length. The easier thing for you to do will probably be to put this one on the underside of that middle pad. Okay, just cut it to length and go to the underside of that one. And as long as you keep the wire nice and flat like this, we won't be in the way of the battery strap. We'll still be able to keep this nice and neat, and it will be a little bit easier because you're going over the top for the first one, under for the next one, and then over the top for the third. And it just makes your life easier when you're soldering. Now, because I'm me and I'm confident to solder this on the top of this one and not interfere with the two either side or touch the two either side, I'm going to go on top for my ones. So I'm going to do this next one across and I'm going to go on top. If you're going to do them all in this direction like this, you just have to be very careful that you get your lengths right and you cut back just the right amount of insulation so that there's no shorts between any of these. But as I said, if you want to make this easier for yourself, cut it to length but solder it to the underside of the middle one, and then when you go to the overside of the top one, you've just got nice separation between all three wires. It makes it easy for you. I'm going to heat up the pad, introduce the wire, move it away, and just having a little look, making sure there's no shorts. We've got another good, decent contact there. So the main thing is really inspect your soldering. Make sure that it looks really good. There's no dry joints. You wiggle the wires a bit. You shouldn't see any kind of movement coming from that. And yeah, I'm considerably happier with the way that looks rather than going in like this and having so much extra wire. We've just got now really just what we need. So you can see the end result is considerably tidier than if we had used the full wire length. So I won't bore you with the rest of this. I'm just going to go straight ahead and do the other three ESCs, and then we will cut back once that's done. Okay, my beginner friends, here we are. We now have this wired exactly as we wanted it. You can see the excess wire that we've lost, which is good. So that's less wire parts to get snagged on twigs and branches and what have you. And if I just move the magnifying glass out of the way now so you can see what we're actually doing, you can see the wire does not get in the way of where the battery strap is going to run through that gap under the ESC, but it's also nice and flat and out the way, and it will be level with the top plate when that goes on, which will look something like that. So that is a nice neat solution. So we've pretty much done the lower deck in terms of the soldering, all but one thing that we need to do, which is to now tin and prepare. Let me bring the magnifying glass back there for you. We now need to tin and prepare here, which is the XT60 pigtail, where our main battery is going to go in, where this capacitor's in. Now, although this capacitor is kind of tacked on, as long as you work one side at a time, it will stay in place. So don't worry that it's only if you heated up both elements this thing would fall out of place, but it won't. Just work on one side at a time. And it looks like it is actually labelled here. You can see GND, which means ground, so we know this is our ground side. You can also see that they've wired the cap the right way because there's a minus on the leg side that is wired to ground. So that will be our black cable, and our red cable will get wired here to the where it says bat, which is the positive side. So I'm going to do the same thing. I'm going to tin these up one at a time, get plenty of solder on there, and then I'm going to feed that XT60 pigtail, which is in this bag here. So it's this this black connector here. It's nice that they've used a black connector. I hate those yellow connectors on most of them. And you can see these wires are already pre-tinned. It's good to have the full length of that, I think. So we're just going to introduce these to these pads once they're nice and hot and full of solder. So let's tin those up. Okay, so you can see I've been quite liberal there, but look how nice and shiny that solder is. There's plenty there, and the cap has stayed in place just as we wanted it to. Now the other thing you will need to do is use a set of pliers, because, or pincers or whatever it is you're going to use, because that wire is going to get damn hot and it will be very uncomfortable to hold. So we're going to have that come just down the side of the capacitor like that. So same as before, what I'm going to do is just wait for my soldering iron to get up to temperature here. I'm going to heat up the pad first, get that to flow, and there we go, just starting to get nice and liquid there. And then I'm going to introduce the wire, get plenty of heat on it, make sure that solder's flowing, let go, and then carefully let go of the wire, and we should have a nice shiny good contact like so. Sometimes I might want to add a little more solder. If I want to do that, if I'm not pleased with it, what I'll do is I'll just tack a little bit on there by being very quick, just like this. And then now I've loaded a bit more solder on, I'll just support the wire and again reheat it so that everything is flowing. And then yeah, that's got a decent amount of solder on there, so I'm really happy with that. You can see we got a nice flat shiny solder joint, and that's what they should all look like. They shouldn't look lumpy and gross and tons of lumps and bits sticking out and spikes. That is not what you want, and that's a sure sign of a very bad solder joint that is likely to fail on you. Okay, so that's more or less falling exactly where I want it to. So same again, I'm going to heat that plus pad up, introduce the wire, make sure it's in position, make sure it's flowing, and then that was pretty good all in one shot there. And again, look at the solder joints, everything's flat, everything, the wire is well surrounded by the solder, and I can see that no matter where I'm flexing the wire, that's all good. And I've got it running down the sides of the capacitor, not over the top of it, because again, this all comes from practice with building quads, but you constantly need to recheck and dry fit the parts. And in the case of this guy, when you put this on, you can see there's not a lot of room between the top of the capacitor and the bottom of this SMA block. And I mean, this can be moved and angled, but you want that as far back as you can really. So having these wires come down the side like that just makes things a little bit tidier. Get one of these magnifying glasses, look, inspect your joints, make sure there's no dry joints, make sure that nothing is touching or a little bit of solder hasn't flicked onto any part of the board, because that can happen sometimes. Just ask any of these seasoned builders and they'll tell you their own nightmare horror stories. So just make sure everything is good, and you should end up with something pretty neat. And as I said, we've got no problem with clearance for the battery strap going in there. Everything is looking as it should do. So the next thing we need to do, we're going to be putting our flight controller back on, and as I mentioned before, make sure to remember it has the arrow on there as well, which you can see facing forwards, and then we've got the battery pigtail coming out the back.
So we've got that orientated. The next thing we need, there is a connector in here, which is this black wire you can see. Let me just pull some of these connectors out. It's this guy. Pull them all out, might as well. This guy here. Now this is the little loom that connects this one at the front. It's the only one that it will fit in, which is a very good idea of them. And there's only one way around the connector can fit, but one goes like that into the front there. And this is carrying power from here to power the flight controller and then all the other electronics that plug into it. And it's carrying the 4 motor signals from each motor. So motor 1, 2, 3 and 4. The order's a bit funny. Again, we'll talk about that later. But all of that's being carried on this cable. So make sure that's in nice and snug. And then we're going to do the same into the ESC board, wiggle that in, make sure it's seated nice and happy, and then what I tend to do is come back this way like that, so that the wiring is nice and neat and inside the stack. So we don't want wires poking out where they don't need to, and you can see that's what you end up with. So the wires tucked away in between the flight controller and the ESC board, no extra wires getting in the way of other things. So that is as simple as that. And then the next thing we're going to do is to take from the kit, you'll have a whole bunch of these little M3 nylon nuts, and we're going to put those down on the top of these standoffs, so that, as you can see like that, we're going to screw 4 of those down, and you just need to do them finger tight, make sure it's nice and solid on there, but don't absolutely wrench it down or use a tool or anything, just get it so it's nice and snug. So there, finger tight, that's good enough. Do those for each, and then we'll do the next bit. So let me show you these other cables here. We have a short cable here with a 3-pin JST, so there's 3 colours there. Yellow, which is your video signal, ground is black, and positive is the red wire. And this guy is going to go in the front into this connector that goes right next to where we just installed the ESC connector. So we're going to put that guy in. Again, it only goes one way round. That plugs in like that, and then this guy will go to your FPV camera. So on the camera that's included with the kit, which is this one here, that will be going to this 3-pin here. And the way you know that it's the right way round, with most FPV cameras I've ever seen, the positive is towards the outside edge of the camera, and as I said, the camera block will be at the top of the quad. So inside your quad it will be like this, connected. But obviously we upgraded the camera in this one to the Runcam MicroSwift, and that will be doing exactly the same in here. You can see I've actually got 2 connectors in here. There's a 3-pin connector for this guy, and there's a 2-pin connector for an OSD board, which is one of these guys. And you plug this into there when you want to change the settings of the camera for better wide dynamic range, etc, etc. These are all good reasons for why I suggest going for a good camera from the off. So that will connect into there when we put the final thing down. It's okay, just left as it is for now. The next thing we have here, which is also JST, another JST plug, but this time it looks to be a 5-pin or a 6-pin. I think it's a 6-pin block, but it's actually only carrying 3 wires. Now this will go into your VTX, and again there's only one way to turn that and to put that in, which is going to be like that, and that is then carrying the final output, because your camera is going to go into the flight controller through this chip here. You can see this long chip, this is your OSD chip. So you'll have an on-screen display with lots of juicy information for you. It will all get its processing done, and then it will come out to the only other place you can plug this in, which is here. And again, I've plugged it in the wrong way around by the looks of things. Have I? Yes. So that's going to go in there like so. And then this guy is going to go to the roof of this, but we're going to tidy the wires up and make sure that they go inside the quad nice and neatly. And then this will connect to the SMA, the SMA pigtail, which is the guy we installed earlier via this MMC X connection. And then the antenna is going to go out there, and that's how your video gets out. So it gets amplified by this, put on the correct band and channel, and sent out to your goggles where you see your glorious FPV image. One thing I will say that's worth noting here is one way to keep the noise down and to keep the electronics from picking up any interference or acting like antennas themselves, is to actually twist the wires up. Now these are silicon insulated and they're really easy to work with. This silicon insulation is what they should have put on the motor wires instead of the plastic stuff. But you'll see that they're all twisted up here. Now they should all be like this. Every case where you've got ground power and a signal, twist them up. That does good things for keeping your noise to a minimum. Every little thing helps, and you can see they're not twisted up here. And silicone wire is really, really nice to work with and easy to do this with. So you literally grab it and you twist it like so. And the nice thing about silicone wire is once you've done the twist, it just stays in beautifully. So we'll finish up the rest of the twist of that. And then the final one here, so this is the only thing that's not in the kit. Now this is for plugging into a receiver. Now it depends what kind of receiver you want to go for. Personally, if you're running FR Sky like many of us are, I would recommend for this quad an XM Plus. That will require plugging in only 3 wires, and that will be a solder job in this case. We can't plug this into it unless we wire the corresponding pins onto the actual XM Plus. That will go to this guy here, I think, because this is the only other place we can wire in, and again the right way round. So you don't have to wire onto the flight controller, but these 3 will have to go to your receiver. So I will get an XM Plus and we will look at doing that. Now back to this VTX. The space that they've kind of assigned for this to mount is on the top here. The actual size of this shield here that's got the print on the other side of it, that's the side that's going to be going down, but it doesn't actually fit between the screws of the top plate. They could have done with recessing these screws and then that would have been easier to mount. So what I'm actually going to do is just raise the height of that top plate a little so that that can sit nice and neatly. I've just got a piece of foam pad here, so I'm going to put the foam pad in there, stick that down. I'm then going to have the VTX on top of there, and then I'm going to secure it by running a zip tie across it through the underside there, just to keep that all nice and in place. And that's what that looks like, all down and secure. Here is my XM Plus receiver. This is a diversity receiver. It has 2 antennas, which makes life much better when we're flying around trees and objects, that we don't lose and get any fail-safing or anything. So big recommendation, very cheap as well too. And this is the cable that goes into the flight controller for the receiver, and on the other end we've simply got one of these kind of standard servo connectors, which we're not going to use. We want to keep things low profile and slim because there's not a lot of room left in that quadcopter. So what I'm going to do, I'm going to make sure I've got enough length there. So I'm probably only going to need about, I guess, you put that on top, about that much. So I'm going to snip the wires, get rid of this bit on the end, and you can watch me do this right now. And don't sit there overthinking it, just get rid of the end. We don't need that extra bit, so that is gone. And then we're going to repeat the procedure that we did earlier, only this time we're working with silicone wire, so it's so much nicer and easier to work with. I'm going to do the same thing, and like I said, I'm just used to this, but if you've got wire strippers, of course feel free to use those, but I'm quite simply going to run my knife over the end there and just expose just enough wire there to be able to make a good solder joint. So that's done. I've added some heat shrink to that. We have our receiver all wired up. We have to find somewhere to put these 2 antennas, but in terms of plugging this in, very, very simple. This goes into this plug at the back, like so. And probably the best place to put this will be directly onto the flight controller, so just some double-sided pad of some kind will do the job nicely. 3M tape's usually pretty good for this kind of thing. And then what we're going to do with these, this is something that I've been doing for a while with these antennas. You want diversity antennas to be at 90 degrees to each other. You run these both in parallel, they're completely defeating the point of working in diversity. The idea is when one goes out of polarization, the other one at 90 degrees to it comes into polarization. Let me just show you what I've done here. So one of those XM Plus antennas is going into alongside a zip tie. This is actually a quite nice thick zip tie, so I don't want that flapping around. Underneath the prop, it's a decent amount underneath the prop. You don't have to worry about that going into the prop. I've never ever on this method of mounting the antennas ever had that happen. It will be absolutely fine. And then what I did was put some heat shrink over it, and the heat shrink is transparent to RF, so there's absolutely no problem with doing that. You can always put a couple of layers on if you just want to add some protection to it. So you can see here I'm about to do the same with that. Going to put the heat shrink over and then just do a general little bit more tidying, and we're pretty much almost there and ready to get that top plate on. We have our two sections. All we need to do now is connect the camera up, poke this VTX cable through here and plug it in, put the SMA connection on, and then we've got these 6 or 7 mil screws. I think they're the only ones that will be left by this point, which will go through these 4 screw holes here to mount the top plate down to the rest of the quad. Another tip for you if you're just starting out: never ever ever power on your VTX without your antenna plugged in. It needs the resistive load of an antenna. This is a transmitter, not a receiver. This is transmitting the video, and therefore it's going to be sending some real juice through there. So if you don't have, especially on these kind of unbranded or not necessarily the highest quality spec of VTX, I'm sure this would be absolutely fine, but there's every chance that running it for any length of period with power to it, without the antenna resistive load on there, you're actually just going to blow it. So there we go, all done, and I think it's turned out really nicely. I'm actually pretty impressed with this, and this has actually been a real fun little build. There's been a couple of little bits along the way. As I said, I stand by it. You really should replace that camera, and you can see the result of which we've now got a camera that's got a chance of having some protection from this front aluminium, unlike the generic one that came with it, which would have stuck a long way out the front. In terms of taking your time, I mean, patience is everything. As I said earlier in the video, do it properly and you'll do it once. This was certainly the case with the motor wiring. As you can see, this is as we planned for. There is nothing in the way of this cavity for the battery strap. They are up and out the way, and there's not too much excess there either, because we cut them down. Obviously that's a bit more involved than just going and soldering them up at the length they came, but learning these are all good habits for you moving forward with future builds. Make sure that all of the screws are now tight and everything is seated and true and square. Go through each one. Remember, these middle screws on the arms are going into the plastic standoffs, so do not over tighten them. However, the others you can make sure those are nice and well seated and down firm, and that includes the ones on the side. The other thing we have to do, of course, is the continuity check. So we put our multimeter into continuity mode, and of course we touch these together and we get a short, the circuit is made, and obviously we'll get a beep. And the quick way to check that would be if I just go into the ground pin on the back. You've got the black wire on the back of the XT60, and I touch somewhere else that I know is grounded, like the shielding on the SMA connector. I know that the ground circuit is absolutely fine. Now, we shouldn't get that noise when we connect to the positive. If we connect to the positive of this, then we definitely have a problem. And there we go, we have no closed circuit. So I'm very happy to report that is now safe to plug a battery into. As I said, let's put that antenna on, because without that we are only serving to potentially fry our VTX. So we're going to make sure we screw this guy on. And the other thing I will suggest is just, once that's on, which we are, is just to bend that back as far as we can in terms of the hinge. So the hinge will go back that far, and now we've got it there. I'm just going to tighten those two screws up like that, and we're pretty much ready to go.
Well done for making it to the end of the video. I hope you enjoyed that, and I hope yours turned out as well as this, if not better, and that this serves you well for some time to come. Now, there was one little modification that I've done here at the end, which was to take the SMA antenna and actually angle it up like that, so that the aerial will actually go back and down, and it's completely fine to have the antenna come out the bottom instead of out the top like that. In fact, it's often the case that the antennas fare slightly better in crashes. Hopefully you won't be doing too much more of that. I've actually chucked my own antenna on here. This is an Axi Stubby, which is one that I really like, but of course you can still use the stock Pagoda antenna. You'll still get great performance from that. Anyway, stick around. I'm going to be doing lots of flight footage on this, lots more testing in terms of its performance on 3S, on 4S, on different props. I will do all of that coming up soon, so stick around, stay tuned, and I'll see you all in the next one.